Okay. All right, so nice. So just what we did last day, right? The last day we focused on sample distribution. That means that's one thing I want to do before we start the point testing, right? Oh, when it comes so far. Right. So as I was saying, we need to do something called right. We need to do something called the sample distribution of right. We need to do so sometimes you will see sample mean, and then sometimes you will see the word proportion. Right? So same principle, but instead of X bar, right? Here's where you're writing. Because is proportion and sample, you're writing P with a subscript S. And it follows a normal with P, right? And P, Q all over N. Right? That's already that we are to consider. All right. So again, when you use this, when you see the term proportion, right? What is the proportion you're using this, right? So let us do one example in case you see it, right? It's not as popular as the next one. Right? So let's say it is known that right, it is known that 5% of students, 5% of students fail apply. Right? What is the probability? What is the probability that out of let's keep the number small, right? Let's keep the number small. Let's say out of 10. What's the probability that out of 10 students, 8% fail? Right? 8% fail. So let's just handle one with proportion, right? So the first thing that we can see, is that P is equal to 0.05. That's right here. That's from the population. Right? We can say that from the population, P is equal to 0.05. Right? So in this case, In this case, what we know? We know P is that, we know N is that small value there of 10, right? We know what Q is. Q is 0. Remember, Q is 1 minus 0.05. So Q is 0.95. Right? So now we can write TF, right? That's the proportion, sample proportion. It will follow a normal distribution, right? Of mean was the original mean was the original p value 0.05, right? Remember it's p and NPQ, right? Right? P is 0. So that was 0.05 by 0.95 all over n and a 10. You make n a little bit bigger. Make n 100, right? Make it a little bit larger, n is 100. So PS follows a normal 0.05. How much is 0.05 by 0.95 over 100? Right, around it off the 0.005, right? Right, so that's what distribution will look like. So now what they asked us for? They asked us for the probability of PS being more than or equal to what? 8%. So that's more than or equal to 0.08. So first thing we have to do, right? We're going to have to standardize that. So that'll be the probability of C is more than or equal to 0.08 minus 0.05, that's a 5, all over the square root of all over the square root of 0.0. Is it 0.005 or just 0.05? No. Change enter 100. N was too small. Change enter 100. Change enter 100. That was a little too small. What's the exact value? 0.00, 0.030, 4, 4, 7, 4, 7. Right? So that'll be the square root of 0.000475, right? Try and use the exact value. Let's see what we get. We will get the probability of Z is more than or equal to, tell me what you get now. 376. How much is that? All right, good. And go to the tables and read out that formula. What on is here? So it's 1 minus 5 of 1.376. I guess I will continue the correction thing I've got to add in here, but I ignore that. Right, go to the table tomorrow, yeah? Remember, it's 1 minus the killing. 1 minus that. 1 minus 5 of 1.376. 0.08. 0.0843. Anybody else got that? Only killing message in. Anybody else got that? Amber, you working it out? Bradley. All right, that's close. I Jesse, thanks. Right, so just in case you lost, all we really doing here earlier, all we really doing here is that if you recognize a question, right? If you recognize in a question they didn't give you, hold on, I have to scroll up. If you go back to the beginning, and in a question they didn't give you like mean and thing, but they give you probabilities. What it means is that now you have a sample distribution, a distribution of sample proportion. So it will change slightly. Right? So instead of having like mean and standard deviation, you end up with this. Right? You have to remember to use this here. Right? Remember to use this here for your sample distribution. All right? That's okay. So when is a distribution of sample proportion, you're using that. When it is a sample distribution of means, you are using, right? You are using this. Right? So just to remember those two things there. All right. So our focus today really is on, as I said, the objective of this whole section here is to kind of find estimates. So sometimes they would ask you, okay, well, I'm gonna give you a whole set of data from the sample, how we getting mean? Right? How we getting mean? Or I might give you a mean and say, okay, check and see if that mean correct. Right? So in this section, what we're going to do is we're going to do number one, we're going to try to get point estimates. Point estimates is actually trying to get the value itself. So we're going to try to get point estimates. The second thing we're going to do is try to get something called confidence intervals. And after we do confidence intervals, we're going to do something called hypothesis testing. All right. So our focus today. Oh wait, we're going on there.
Right, I must leave my butt out this. What's it do? Rejoin. Or this person was following me.
All right. So head up point testing. Right, everything I write down here is the way that we're going to find point estimates. That's estimates for proportion, estimates for mean, estimates for variance. And every time I estimate something, we put a hat on top of it. That little hat shows that the estimated value. Right, so to write all that, but those are the formulas we have to learn, right? The problem with the standard with the variance is that if they don't give you a sample variance, you have to work it out from scratch. So you can use any one of those formulas there. But the formulas that you're using is based on what they give you. So for example, if the question give you x bar, you can use the first one. If the question give you the sum of x squared, you can use the second equation here. Right? Otherwise, you are using first one on top. So it's based on what they give you. So copy them down. We're gonna just try. It's a little tedious because we actually have to go down standard deviation, right? Right, anybody writes in there? Larry, any writing, sir? Larry, any listening, sir? Anybody writing still? Darian? Say yes or no now? Anybody
Yes,
writing?
only last not, only last one.
Oh, yeah. Darian, boy, hey. Get my parents' numbers, yeah. Somebody finish it, Bradley. So it's based on the values they give you, you'll know which one you can use, right?
Yes, sir, you can go ahead.
Alright, nice. So I'm gonna give you one, but here's what I'm gonna give you. I'm gonna give you a set of raw values. Right? And then I'm going to ask you to find. I'm going to ask you to find mean. And I'm going to ask you to find variance. Okay? Take your time and work it out, right? But I think I gave you a summary of steps, so you'll be able to do it a little bit easier. Oh yeah, now see that. That's the material person. Right? So try that out for me. So a railway enthusiast simulates train journeys and records the number of minutes to the nearest minute. Trains are late according to the schedule being used. A random sample of 50 journeys gave the following times. Those are the times. They don't have to manually go and do auto, right? Because I gave you the sums at the end. So I gave you the sum of x and the sum of x squared. Calculated 2 decimal places on bias estimates of the mean. So I want to get estimates of the mean and the variance. Okay, so you're using the actual formula there. The mean is easy, right? Because they gave you sum of x already. So which formula you think is the best one to use for standard deviation? The first, the second, and the third. For variance, I mean. Which one would you use? The first formula, the second one I gave you, a third. Based on what you have. Remember, you have sum of x and sum of x squared. What you all think? Right? Most people say it is two, because you have sum of x squared. Right? If you use the second, then every x value, 6, 17, you have to minus x value. You have that 50 times. So the second one out it. And number one, I didn't give it a square, right? So you're using formula 3. Go ahead, find the unbiased estimates for mean and variance. Remember to put a little hat on top, right? Go ahead, do that yet? Right, so just use the formulas, right? What you got for the mean? What you got for the mean value? Right, Jess, you got 14.76, nice. Now do the standard deviation. Right, so I'm just checking out your working. So what you'll get for the first part, you'll get again the mean, which is x bar. That's the sum of x all on n. The sum of x I gave you was 738. So the number of bars is 50. So that's 14.76. Now, to get the variance, right, that'll be 1 over the best formula to use will be the 1 over n minus 1. Sum of x squared, because we have that. Sum of x all squared on n. So that's 1 over 50 minus 1 by 16,526 minus sum of x, oh, that would be 738 squared all over 50. And when you work out that, you should get 114.96. Okay. Amber, you there? You got that? You got that, right? Daria, you doing anything? All right. So that's the way you work it out, right? It don't matter which version you use. Look at the difference. Like, look at the two I gave you. If you use the n over n minus 1, if you use the n over n minus 1, then it will be the sum of x squared all over n. Right? Minus the sum of x on n all squared. So that's different versions. So you could have used the first part in the third formula I gave you. But you have to use the third version. You can use this version here or this version here. That's okay? Yeah? Right, but you have to learn that. I don't think somebody can just do my favor, check on the formula sheet and see which version for variance they give you. Check on the formula sheet now, please. Oh wait, I have it. Oh, they did not. They don't have one. That one for group data. They only have one for group data. So bad news. You have to learn all these things. You have to learn all three. Okay, because based on what you have, based on how they give you the values, they will know which one to use. If they did not give you some x squared, we're going to have to do the long method I did in that maps. Find x, well, find x bar, have a table of x minus x bar, work it out, square it. You have to do all that. So you'll have to use the second formula. If you don't have sum of x squared. Right? Actually, it might be easy to square this time, have to write down 50 values. By the way, they don't give you more than 10 to like that. Right, from this same data, I want you to find something from it. I just go and zoom in a little bit so you'll see it better. Right, using the same data, I want you to estimate for me. Write this down. Estimate the proportion of trains. Estimate the proportion of trains that are more than 25 minutes late. Right, using the same data, this is like part 2 problem, part 3. Estimate the proportion of trains that are more than 25 minutes late. Come on, tell again. More than 25, right? Tell again. So the one a proportion, right? So out of 50, how many times is more than how many times you will leave more than 25 minutes? So let's check and see. More than 25 is good. More than 25 is 1, 2, 3, 5, 6, 7. Anybody seen anymore? It has to be more than 25, right? See any more online? Anyone? So if you're not seeing anymore, the proportion is simply 7 on 50. That's it. Right, so that's the way you do proportion. That's the way you do mean, that's the way you do standard deviation. That is all. Right, let's just do one more. We can do one more, should I show you? It's 2021, right? It's not a whole question, but the part 1 and 2, right? Oh, wait, no, wrong thing. Give me number 5. I'll go. That is very cool. I pull up the wrong thing. Anyway, let's use this one, this same 2021. I think I've already pulled up 2022 by this. So they want the appropriate distribution, we'll come to that just now. Find the mean and standard deviation. They want those things, right? They want the mean and standard deviation, and then when you finish, they want the appropriate distribution for the sample. Try that. Yes, one I'm looking for a square. Let's see if I can find it.
Did I get you? Amber, send the answers now. Oh, it's not you, Amber. Right, the appropriate distribution to the sample. Amber and Darian are written on the right? Right, write the distribution for the sample mean as well, right?
No, just now is mine.
Darian, where's yours?
Oh
Darian?
God.
So tomorrow work and stop talking to everybody around there.
Sir, it was something I think I'm doing the work.
So you ain't finished that?
Um, almost done on the second part, the standard division.
Alright.
Yeah.
No reason, no reason. I'm on no meeting meeting. Oh, wait, that's all right. Right, writing distribution after, right? That's what we did last, that's on the board. You have this distribution? Okay. Right, so they want to get the unbiased estimate for mean, so that'll be the sum of x on n. So that'll be 1600 over 150, what you get it? 6.5. Sure. Hold on. 10 point. And then to find sigma squared, well, sorry, not sigma squared, you want standard deviation, right? But work out this first and then square root it and give them standard deviation. Okay, that would be, again, based on which formula you're using, right? So that's 1 on n minus 1, so that's 1 on 149 by 18,040 minus sum of x squared. That'll be 1600 squared all over 150. 6.5. After square root. They give you 4 squared. All one square root. So the square root of 6.5. What is that? One plus. Oh, killing, we get to have the standard deviation, so you have to square root it, right?
Like you square it. And then the last part underneath, X bar follows a normal distribution with mean 10.6 and the variance 6.53 on 10. Right, remember it's sigma squared on n, right? So it's 6.53 on 10. Right, that's the distribution with the sample mean. Okay, I'm adding your value. Carry on, you're taking too long, boy.
Sir, I had get it.
Yeah, but you didn't message or say something, sir, I get that. Or I get this value. How I know you get that?
Huh? I forget, sir.
So Darren at the habit there and it might work it, right? Suppose the question was different. Suppose the question said to find the estimated variance, but they didn't give you this. Instead of giving you that, here's what they give you. They said that the sample variance is equal to 4. Suppose they give it that. Suppose that the sample variance is 4. And they said find the standard deviation. Or find the variance. Find the variance of the mean or the normal. Sorry, of the population. What you will do?
Wait, sir, could you repeat the question?
Oh. Suppose they give you a sample variance instead of those sum values. Sum of x and sum of x squared. Suppose they give you the sample variance is equal to 4. How will you estimate the population variance?
You would use the formula for variance of the sample and make the population the variance, the subject of the formula, the normal variance.
So which formula are you using? 1, 2, or 3?
Um, 2, I think. No, 3. If I copy them correct.
You copy them wrong because you don't know s squared. You don't have that. Remember, sample variance s squared. So if you copy down the note properly, you should have n over n minus 1 by s squared. You have that?
Yeah, I have it.
No, the first formula I gave you was the first formula I gave you for sigma squared. N over n minus 1 by s squared. Go back to point estimates. Under the formulas for standard deviation for variance.
Yes, sir. And that is the third one?
So that's the first formula s squared. Oh, you mean like that?
Yeah.
No, I gave you 3 formulas. I gave you 3 formulas to find population variance. So I
Oh.
meant the first one, yeah. I meant the
Oh,
first
that one. Yeah. I seen it now. The first one. Yeah, the first one.
Okay, so you have to look out for that. If you do have x bar, summa, if you do have sum of x and sum of x bar squared, and it just give you the sample variance, which is x s squared, you can just use that and the n value and find the population variance, estimate the population variance. I was looking for one with the final say. So can we check the group chart? Which group chat? What's up? Huh? But that's the formula you have. Sum of x squared on n minus the sum of x on n equals squared. Yeah, I've seen this one too. It doesn't change the value by much, huh? It doesn't change the value by much. You use it. And you got almost the same thing, huh? When the sample size is large, it doesn't really change the value by much. It was real close, and yeah, it doesn't change it by much. But I wouldn't give it this one because I will give it the first one I will give it the n and n minus 1 s squared. So if I use that, then when I simplify, I will get the one I gave, the 3 I gave. So I wouldn't give it this one. But it is the one I use in ADMAS something to find standard deviation. But if you see the problem here is that when you're estimating, right, you have to introduce something called you have to put in something for the errors. And the cater for the errors is be 1 over n minus 1, not 1 over n. So this formula here didn't really cater for that error. Get what you just call it, just call it something like degrees of freedom. But it has to do with the number of errors that are being calculated. So because you're estimating something, you're kind of off by 1. So therefore n minus 1. If you were estimating 2 things, then it'll be n minus 2 and so on. Right? So because we estimated only one thing here, which is the population variance, it's 1 over n minus 1. It's not 1 over n anymore. 1 over n is when you're finding variance. You're not estimating. You're just finding variance like a sample or something. Or you have all the parts of the population, you're finding it. But once you're estimating, you have to introduce errors. So you have one error. So you just put 1 over n minus 1. That's okay? That's it. So the formulas will give you very, very close answers. Right? But the reason I gave you 1 over n minus 1 is because you're estimating something. If you're not really estimating and you have all the values, right? Like for example, sample variance. If it's 10 in the sample and you have all 10 values and you're working it out, you don't need to have on 1 on n minus 1. It's just sum of x squared on n, same one that you have. But because we estimated population variance, you will see the 1 on n minus 1 outside. All right. So my advice is if they are finding this unbiased estimate, then use 1 over n minus 1. All right. So that formula you give me there is technically s squared. All right. All right. All right, Claudia, we have one more thing to do, but I wouldn't rush today because it will take some time. It's something called confidence interval. So I'm gonna give you a guideline, right? So we were actually working out the mean, trying to estimate the mean, and well, we got like 10 point something. What we're going to try to do is to narrow down, create an interval, so where the mean might lie. So our solution will be okay. Well, here's what I am 90% sure that my mean is between 10 and 11. That is called a confidence interval. I'm going to show you how to develop them and we'll get them out next week. Right? So we will be doing this, right? All right. So that's it online. Right? You all can log out. People who doing the SBA are going to send. Wait, this thing wasn't recorded. But nobody's on this, it's not that simple, say. Right, those who do in the SBA, I'll send you back a next sample to show you the way we have to write it up, right? So I'll change it slightly and I'll give you an idea of what was to be done. And I want to see something by Saturday. Okay? A first kind of calculation, just calculation, I want to see by Saturday. And next week you can take your time and write it up. All right? You all can log out. I'll see you all next week, right?